Okay, I just uploaded manually. You just access those data and then download it. Good? Yeah. Just weird. Does this link still not work? Okay. Okay. So just let me recap the last lab first. The last time we made a game of life, right? Using only patches. So like I said, there are 4 components of the logo that you can make it as agents. First, title totals, there's mobile agent, and the patches, which is the background, like a cell base. And then link is the link that you can make it network data, and then observer. So each one, we're gonna use each one later. But for today, I mean, the last time we used the only patches to make that simulation. But today we're gonna use total and patch at the same time to make a butterfly model. So here, let's look at the attributes, the properties of the total. So I sometimes say properties or attributes or variable, but just make sure that those 3 are all the same in this model. So the properties is that the variable each total has to have. Person who, which is this ID of each total, and heading is the direction of their head, and coordinates, which are their locations, composed of course X and Y, and then shape and size and color and hidden, or also the neighbors or and so on. And then there are some like attribute, variable that you can make up. Okay, so totals are created during the run of the model by the primitive, and the code named create total. So you can make a command like create total or CRT, and then the number of total you want. So if you want to make a 3 totals, then we can just put CRT3. That's all. Okay. Yeah. And okay, there's other so of course like I said, you can also make up the properties, and you can just give them their own properties like this way. So last time we look over how to make the properties, like own properties inside of each patch, right? But here, if you want to make the properties of all on the total, then you can just make a command like totals on, and in the bracket, then you can just put the variables name that you want to make. So like a happy and question mark. So question mark is like is when you want to make the Boolean variables, right? Yeah, and then similar nearby, another nearby, and total nearby. So now in the figure, you made 4 variables right now. And then if you made 4 variables, then here you can see there are 4 variables is already added to each model, right? So you can check it in that logo interface too. Okay. And the command to ask the total do something is the same as the patches too. So like ask total and ID of the total and then do something, right? So it's the same as patches. So like last time, if you remember that you can, if you want to ask patches to do something, then you can ask patch and then their coordinates, right? 0, 1, and then show something in bracket, right? So here, because total use their own ID, so you can just specify the ID to indicate the total and then ask them to do something. Okay. All right. So the difference between the distinctive differences between the patches and total is that the total can move. Patches cannot move, but total can move. So there are 2 ability the total have. First is turning. So we can just change their heading. Like to the left or right, or face and face. So those are name of functions. So you can just put, hey, as total and then left, then the total we're gonna, change their path direction to the left. We're gonna use it maybe lab 4 or 5, I don't remember, but we're gonna use a movement function for today's lab. So if you want to make total move, then you can just put forward, and then the total is gonna go forward, right? According to their heading direction. And then if you put the move to, and then put patch or move to some specific coordinates, then they're gonna move to that destinations. And then you can also set XY to move to the destination XY. Right? So there are several those functions. We're going to use move to for today. All right. Yeah, we don't have to get it out right now. Okay, so please start net logo and open the HTML file. So today's model is butterfly movement. The butterfly model is very interesting basic simulation that where total move to the higher altitude from the lower altitude. So here altitude you can make the patch at or altitude, and then we can put the total and then let total move from the lower altitude to higher altitude. So that's the like process we're gonna make. Okay. Before we start, do you have any questions about anything like that level or Lab 2? Anything? No? Okay. So first thing we need to do is, like the same as the last time, make variables, right? So here, today, let's go to code section here. I'm going to zoom it again. Okay, good. So we're going to make a three kinds of variables, like 3 types of variables. First one is global variable, right? So like I said, if you want to make a global variable, then you can just put in globals in bracket. And then if you want to make any variable inside each patch, then you can make a code like patches on, and then totals on. The code is to make the attributes for each total, right? Yeah, we didn't specify any, declare any variable yet. Just make it empty. And then we make elevation variable, which is the attribute for each patch. So you can put the elevation inside patches on, like this way. So if you put this, then now every patch has elevation attributes, right? Their own elevation attributes. Okay. Oh, and then just don't forget to save it. So I just recommend you to save this netlogo file where the txt file is saved. Okay, so just put those 2 files in the same repository. Okay, because we're gonna use that txt file later. So just put in the same repository. Good. So that it look like this. So your netlogo file and txt file are in the same repository. Okay. Okay, good. And then right now, and then after that, we're gonna make a setup function. Okay, like I said, the setup function is like a basic function we need to make like all the time. So like this way, the two setup and end to make a setup function, right? And then CA is a clear all, to clear everything to initialize the model. And then ask patches to do something, we just make it empty, right? And then reset ticks. So reset ticks to initialize tick to 0. The tick is time unit, just for a cap. Good. Then make sure there is no error when you save it. Just to check it, and you can click the check if there's something to debug or not. So if there's no message, then you're good to go. Okay. And then there are several some command we need to put. It's quite long. I'm gonna explain later, but before that, please put the command here like this way. Yeah. So in the patches, I'm gonna explain later. Just put this comment right now. Yeah. Yeah. I mean, is it like a IDCO? Yeah. Oh, really? Really? Okay. Yes. Seems. Yeah. I guess if they have new softwares, it was set up this support. Yeah, because they have yeah, you could do that. You could do things like Google's. Yeah, that's the thing that you get from the class. Maybe not just for the semester, but yeah. But we need to. All time. Okay. So the command here, we use a let, right? So it's the first time we use the let is to make local variable. So when we make the global variables or variables or patches or total, we can just put the name of the variable. But here, if you want to make a local variable, then you need to put let here, and then name of the variable. Here is elif1. So if you made L1, then these variables, as you know, can be only used in this ask patchy function here. Okay, and if you operate it here and outside it, the L1, we're gonna be disappeared. Okay, you cannot use it. All right. So here is like a temporal variable, right? So we let ELV1 variable be 100 minus distance to xy 30, 30, right? So it means that if this patch, because this ask patch function, we're going to operate it for each patch, right? So if that patch, one patch that is located in maybe 30, 30, right? Then the distance to xy 30, 30 will be 0, right? For that patch. Then the patch ELV1 variable will be 100, right? And the further from the 30, 30, then the variable will be smaller, right? So basically, it is to make the background the digital elevation model. Okay, so the peak here is 30, 30, and the other peak will be 120 per 100. And the patch that is located in 30, 30 will have ELV1 to as 100, and the patches at 120, 100, we're gonna have 50 ELV2, right? And then there's two peaks here, right? And then there's some, the like mountain elevation we're gonna be made. So, and then there is there should be some overlap, right? If you make like this way. So this is how to address the overlapped patches. So if this patch, P patches ELV1 is over, then the upper than ELV2, then we will choose ELV1 as elevation, right? Yeah. So either ELV1 or ELV2 will be, and one of the ELV1 and in the ELV2 will be the elevation of one patch, right? Because and then that elevation will be the real elevation in the level background in Word, like I said. So here, let's go to interface, and then I mean, before we need to check this.
Is distance xy like in a straight line distance, or like?
Yeah, just just straight distance. Yeah, that's all. Yeah. On here. Yeah. Okay. So and then go to the interface, and like we always did, put button. Okay. Just click, and then click button, and then make setup button here. Yeah, to connect the setup function in the code automatically. So if you so if you put the setup here, then it's the name of the setup is the same as this setup, then it's gonna automatically be connected. And if you click the button of the setup, then the function we're gonna be operating. Okay. All right, and then here we have like we need to make an instance more larger. So let's go to let's click the word and then click edit. Okay, and then go to, maybe I'm gonna set location of origin to corner, and then XY can just make it larger enough, maybe 149 to make 150 by 150, and maybe patch size to 3 or 4. Right? So just and then please uncheck this word wrap. Okay. So if you set up like this way, then click apply and click the setup again, then you can see the two peaks. Is it? Click OK. Yeah, this, we're gonna be shown up on your screen. Is there any error or issue?
Not getting
Okay.
peaks. That looks,
Yeah. Oh, yeah, you need to make it more, maybe larger, so go to edit, yeah. Click, yeah, edit. Okay, and then
This.
just
oh,
text
I thought
to-
it
Yeah.
was-
well, text size is too big, I guess. Yeah, your text size is too big, so let's just go to edit. Yeah. Then maybe decide to 3. Yeah. Good.
Yes,
Okay, yeah. Do you have any questions? Yeah. Oh, yeah, so you need to uncheck the wrap with the word. Oh, right, yeah. Yeah, that's right. Then, yeah, we'll fix that. Good, thank you. Okay, seems like everyone's on the basic page, right? Good. Oh, yeah, that's good. Yeah. I mean, I think it's. I don't know. Oh, it's a slightly different. It's okay. There's a gap between the two. But it's the same, I guess. Yeah. Okay. No questions. Okay, so now we're gonna add total. Okay, so now so far we have set up the patch, right? So each patch has their own variable elevation now, and then we're gonna put the one total on that patch, okay, on this patch background. So you can put this. I mean, in the setup, after ask patches function, you need to put the create total here. So control, yeah. So after the setup, you need to put this. I mean, oh no. Just yeah. After the ask patches function, you need to put CLT here, create total. So that once you hit the setup button, then the patches were gonna be initialized. And they also create the totals, right? Of course, you can set color green or set color red to set color. There's several things, but or you can set heading. I don't remember, but maybe it's a degree. So like 90, then you can change the header, I guess. Can check it works. All right. If you can do that, but right now we can just put those two commands, exercise and xy. Okay. So xy is 85.95. So yeah, you're gonna be located in that location. So go to interface and then click the setup again. I think it's too small. I'm gonna make it a bit big. Yeah, so you can see yeah, I don't know how to make the setup this work bigger, but it's good to see. It's clearly you can see. But okay, so here now we can put one total, right? So if in this code, like I said, if you put 1 after the CLT, then it means that you make one total, right? just change the number, okay, and then try it. And there should be a lot of totals you can make. Like I'm gonna go with 10. Okay. Then you can make 10 totals like this, right? With random headings. Okay, but okay, just for lab, you know, we can just put 1, okay? We're gonna make lots of totals later. Okay, and then we're gonna control the model flow by making goal function, right? So to make a goal function, you need to just make sure that you see this end, right? To finish the setup function, and then you put to goal function after the to setup function, okay? Like below the setup function, like this. So here, we're gonna make another button, right? Named the goal, right? That's why you need to put to go function separately. So to go and end, and inside, just write the code, and then I'm gonna explain what is going on. Okay. And there should be error, okay? So don't worry about it. Okay. Okay, so here, now we use ask function, right? So ask turtle to do something. And then we ask turtle to move, right? But actually move is not an inner function. It's already defined in that logo. So move is like the function that you need to make, okay? And then a tick is like a 1 tick. If you put tick, then 1 tick will be elapsed. And then here, if ticks, so if current time is over 1,000, then stop. Stop is inner function. Okay, so it's already defined in that logo. So if you put the stop, then the simulation is stopped. Okay, so it means that if the 1,000 is the time, the simulation time you set. Okay, so let's define the move right now. So what is a move? So move is a function. So like I always make the setup and go function always separately defined. So I always make a comment here and then put the other function below this here. So just to set up and go here, and then maybe put some lines here, and then to the other functions you can put below here. This is my habit. So okay, so we now make a move, and then the error message will become, right? Okay. Okay, so let's see. Just make a comment like this. And there should be error, don't worry. Okay, so here we use if else, the conditional statement here. And then we make a random float, ranges from 0 to 1, right? And if this random float is, lower than Q is, we didn't decide yet, right? And then appeal is, this, automatically it changes to blue, right? It means that it's inner function. So up here is move total to somewhere like a high variable. Okay. So now which variable we're going to use? The elevation, right? Of patch, right? So this total. So because the move we're going to be operated in for each total, right? And then that total, we let the total uphill, right? Move uphill with elevation variable. So if the elevation, just search the elevation, search the elevation surrounding them. And then if it finds some elevation that is higher than the elevation that he is located in, then it moves to high elevation, right? So that's the uphill function. And then if not, right, if the random float is below then it not, is higher than Q, then it moves to one of neighbors, which is this random neighbor, right? So here neighbors is Queen's neighbor. So the 8 patches surrounding him, right? Okay, so and then we need to put Q, right? So the Q is global variable. So we can just put Q and Glover's bracket here. And then maybe and then Q in the setup, after clear all, we can just put Q equals to 0.4, set Q. Yeah, oh. Is it? Yeah, not equal. Set Q 0.4. Yeah, sometimes very confusing, use the net logo is weird language. Yeah, so you declare Q in global variable and then set Q in setup function. So you can, if you hit when you hit the setup button, then the Q will be initialized to 0.4, and then you use the Q in this move function. Okay. You do that, then just go to interface and then make a button named Go, and then you can try by clicking Go several times. Then and then see how the total move. Yeah. Of course, you can make a Go button with forever function, right? You can check the forever function to simulation go constantly. It's a little bit no. Oh yeah, no, yeah, there's behind. Okay, so yeah, because you just copied, so oh, right. Okay. The heat is widening mass, but yeah. Yeah, that one. So corner under that four, under that four. Okay. So the exercise 2, maybe 3, and then just one lap. Yeah. Okay. So now the total we're gonna move, right?
I think. Maybe.
Mhm. Yeah. Did you check where the hit the check button? Oh, yeah.
Sorry.
There you go. Okay, so now the total is supposed to move, right? Yeah, whenever you click, or if you click the forever, check the forever function, then the total is gonna move very fast, so you can see. But so it's a move like for 1,000 ticks, right? Okay, so now we put maybe let's see, pen down, yeah. So you can just put pen down comment here. Yeah, so you can just put the pen down, comment here, yeah, in CRT1, and then you can see, you can track their trajectories of their movement, right? Like this way. Right? And the color will be the same as the total color. Okay, good. Okay, and then right now, let's see. Yeah, so we're gonna create movement variation, by making lots of totals and then change the Q. Okay, so I'm gonna show you how it works. So let's make another variable which name is used. Used. And then put question mark to make it Boolean variable, right? So in that logo, you can in Boolean variable, true or false or 0 or 1. Okay. This user variable we're gonna be, become true when the total stepped. Okay. And then the patches that the total never go through will maintain its variable, false, right? Okay. And then initialize the used first. So first, yeah, set used first. Here, because the this used variable is declared in patches on, right? So in ask patches function, you can put this command. So you can put this command inside the ask patches function, right? Oh, not here. Sorry, here. Yeah, like this one. Yeah, in the bracket. Okay, so that means that we initialize the used, the variable name used to false, right? And then when we, change the state of the variable used to true, is when here to move. So you need to put this set use true command inside the to move function, right? And there is actually something that you might need to know is that, so if you put this set command after this if else statement, then it means that when the total go to that destination, then the patches on that destinations used will gonna be true, right? But if you put this set command before this if else statements, then the used variable, on the patches where the total is already here, we're gonna be changed to true. So it's depends on where you put. Actually, it's quite different results we're gonna come out. Right? But I'm gonna put in after here, after this if else movement, okay, to change the variable when the totals go to that, right? And then yeah, there should be no error, right? Okay, out here. And then let's go to interface and then check how many patches the total step, okay, to go to their destination. So let's make a monitor, okay? That button, let's make a monitor here, and then put the code like this way. The count patches width, right? It's just I think I recommend you memorize like those basic structure like ask patches something or count patches width. Okay, so this is like the group structure. So you might need to memorize. So count patches width, and then you can put some conditional statements like used equals to true. So you're gonna count the patches that have use function being true. Right? So click OK, and then set up and go. If when you click go, right, and then if total stepped the patches that he never stepped, then this count will gonna be increased by one, right? Like this way. So yeah. So except the duplicate step, you can count the number of patches that the totals actually step. Okay. And after that, we're gonna make a slider. Okay. So to adjust the queue. Okay. So in GUI, in graphic user interface. So right now, Q is here. Q is declared in this global variable in CUI interface, right? The character user interface right now. But we're gonna move this Q to interface, the GUI. Okay. So just erase the Q in globals like this. Okay. So erase the Q from global variables command, right? And then erase this command too. Set Q 0.4. Okay, just erase it. Okay. And then let's go to the interface, right? And there should be error, just ignore it. Go to interface and then make a slider. Next slider. And then they put here, and then just put Q here, global variable Q, right? It's the same as the global variables. So, and then maximum we're gonna be 1, right? And then increment, which is a step, will be 0.1. Okay. And then value is the initial value. So you can just put 0.5, right? And then click OK. And just, you can adjust the Q and how the results are going to be changing, okay? So the more Q, I mean, the higher Q, the more straight line are going to be shown up. So if you click OK, And if it's a 0.5, right? The line we're gonna do like this, but if Q equals 1, then it's almost like straight line, right? Yeah. Okay. Yeah, just briefly explaining why it happens, because this is code, right? Because the Q, if Q is 1, then this statements we're gonna always show this first uphill elevation is true. So I mean this just random this how can I say? Yeah, these conditional statements will always be true if the Q is equals 1, right? Yeah, because Q is always 1, then this random flood ranges from 0 to 1, it will always be lower than Q, right? So the one total we're gonna always uphill, right? So it will never, move random. Yeah, that's the way why it happened. Yeah, but if it's a 0, then it's totally random movements, right? Okay. So this is second last one, the calculating collider width. So collider width is like the width of their trajectories. If it's a really straight line, the collider width is really small. If it's total random move, then the collider width will be larger. So it's like an efficiency of their movement. Then how to make it? Okay. You have any questions so far? No. Okay. So now we're gonna make a one variable named the start patch. So let's go back to the code interface and then put the start patch variable inside the totals on. So yeah. So right now each total has start patch variable. Okay. And then go to CLT. Yeah, CLT statement, and then put the start patch patch here. So put the command that initialize the start patch variable. Okay. Of course after the set XY, because because we need to initialize the totals location first, and then set totals patch to the location of patch here, right? Okay. And then we need to report. So here there's a new type of function. So when we want to make a function, we always use a to and function name and end to finish the the function. So right now we're gonna use report function. So let's put the report function file button here. Okay. So NetLover is a really flexible language. So you don't have to, of course, make it to report. You can just make it a function, just to, and then you can put those things, those command in the interface to report it. But you can also put all the command in the CUI and then just put the interface later, very briefly. So here, the to report is the make report function. Okay, it means that it's almost same as the return in any Python or R. Okay, so we're gonna return something. Okay, and then so here we if you put report here, then I'm gonna report this variable by the name of this variable. Okay, and then we can just use this collider width in the interface here to refer to this variable. later. So here we made two variables, local variable. First one is num patches used, right? So num patches used is the number that counts the patches with this. So use equals to true, right? So that counts all the patches that has the used being true, right? And the other one is average distance moved, and it the average, the mean of the distance to start patch. Okay, so it means that the longer distance from the start patch, and the larger number of the ABGB moved. Yeah. And then you can divide. So num patches used divided by ABGBs moved. So yeah, it means that the more patches you step, the total step, the corridor width will be larger, right? Means that inefficient movement, right? If it's efficient movement, it means that which is a straight line, then this corridor width we're gonna be really, really small, right? Okay, and then go to interface, and then make another monitor, and then report name is what was it? Corridor width. Yeah, corridor width, and then click OK. And then you can see the corridor width of the total. So if you make it successfully, then maybe you can change. I mean, you can make several totals and then see how they are moved. So yeah, you can make 10 totals and then see how they move. The sum of it's like this. Some totals go to this peak, the sum totals go to the other peak. That's right. Okay. There error or yeah. So we have an assignment that is very simple. It's not going to be difficult. It's almost the same as the last one. But here we have additional task. I mean, not task for the assignment. It's just for additional lab contents. So the time is almost, but I'll introduce what is it. So we made up two picks with manually, right? But right now we're gonna use a TXT file to make DEM, the digital elevation model. So it means that we're gonna import the data. So import the data for making the DEM. So how to make it? So here we have elevation data. We're gonna import it to that logo to make the background. Okay. Yeah. Before that, you have any questions? Go ahead. Any question in Zoom? No. Okay. Before that, I'm gonna open the TXT file. Okay. And then if you open it, I mean, you don't have to open it. Okay, I'm gonna show you. There's three columns here. First column, we're gonna be X. Second column, we're gonna be Y. And the third column will be elevation. Okay. Yeah. How to code? How to make a code to import this data? Just So let's just, I just copy this comment and just explain how it works. So let's just file open, right? So this is only possible when you put the elevation txt file in the same repository where you save this netlog file. So if it is not, then you need to, specify the directory like this way, okay? But this is really like mending. I mean, this is really like what I want to do. So just put the elevation.txt file in the same repository where you saved that logo, and then just put like this while, and then bracket. So it means that while if this is true, then we just do forever. Okay. So here, if the file, so we read the file to the end, and if the file is not end, then we keep doing, right? So here, we let next x variable to file read. So it means that if you put the file read, then this command will read the first column, okay? And if you put the file read second time, in this second file read function, we're gonna read second column, okay? And then the third one, right? We're gonna read the third column. And then the first column will be next x variable, and second column will be next y, and third column will be elevation, okay, right? So this is the structure of how we read. And then as patch, x and y, right? So this is a like basic structure, right? As patch and their location. So as patch, next x, next y, at next y, x at next y, to set their elevation to next elevation. So next elevation is also the variable that you import from the txt file, right? And then make sure that it's false file. And then of course you need to delete some functions that's related to like DEM, like we don't need let ELv1 ELv2. And then we don't need this if else. So this is a little tip. If you want to make the comment at once, I mean easily, then you can just block. I mean, what is it?
Highlight.
Sorry.
Highlight.
Yeah, highlight it, and then just put control and semicolon. Okay. Yeah, control and semicolon. And then also you need to change this range, right? The color range. Yeah. So here, yeah, I think I didn't explain it, but like this set the color and then use a scale color, right? And then you can put the color green or red, and then put variable and range. So you're gonna automatically make this color by the scale. So 100 will be black or very, very dark green, 50 will be green, and 0 will be white. So right now, like this instruction said, the range will be 450 to 650. So you can put scale 450 to 650. Yeah. Okay, and then check. Gonna go to interface and setup. Then you can see the elevation from the text file. Okay. Right. So yeah, I'm gonna be here until 1:10. So please, if you have a question, just feel free to ask. Yeah. Good. Yeah. So this is for today. Thank you.
For the text file, it's
Mhm.
gotta be like tab delimited.
Yeah, tab here. Of course, you could, like change some code too.
Okay.
But yeah, the tab.
By default.
Yeah, tab. So if you want to make, so there is like some project they the last time some team want to use their own TXT, like so many errors because if the EM is too large, then the load can explode it.
Yeah.
So yeah, that's bad.
So you can tell when you hit setup, it takes now like a second.
Yeah, yeah, yeah.
Not even that big.
Yeah. Okay, I'm gonna stop recording.